Quantum telepathy goes real. How lasers, ions outsmarted logic. Let's find out. Let's go through this. Physicists have successfully played a mind-bending quantum game using real-world quantum computer in which lasers shuffle around ions on a chip to explore the strategy's behavior of qubits. By creating a special knotted structure of entangled particles, the team demonstrated that today's quantum machines can already outperform classical strategies in certain tasks, and with surprising reliability. This high-stakes game isn't just for fun. It's a proof that scalability, error-resistant quantum computing may become closer than we think. Playing checkers with ions. Quantum game on a tiny grid. Imagine playing a game of checkers on the tiniest possible scale, played not with plastic pieces, but with individual ions moved precisely by lasers across a tiny grid. That is the concept explored in a recent study published by Physical Review Letters. A team of theory physicists from Colorado developed a new kind of quantum game designed to be ran on real quantum hardware, a type of computer that uses particles like atoms to perform complex calculations. The researchers tested their game on an actual device, the Quantum System Model H1 quantum computer, built by the company Quantitanum. This study was collaborated between scientists of the University of Colorado Boulder and Quantitanum, which is Colorado-based. According to the study, the experiment offers a glimpse into what today's quantum devices can already do. What are quantum computers good for? Small-scale quantum computers devices are rapidly coming online. They are really pumped. The question, what are they good for? They answer a lot, potentially. Scientists believe that quantum computers could one day perform a range of tasks with a speed that's unheard of today, such as discovering new drugs to treat human illnesses or explore how atoms and electrons interact at a very small scale. But building a quantum computer that works as desired isn't an easy goal. Unlike your home laptop, which runs on bits or switches that flip to either a 0 or 1, quantum computers hinge on a concept called qubits. Qubits, which can be made from atoms or other small objects, take on values of 0, 1, or, through the strangest of the quantum physics, both simultaneously. I find that interesting because I feel like humans are going to start living longer if the science and quantum computers and AI start to figure out all of our problems. Don't you feel like humans will start to live longer? Maybe even at some point having the chance to become immortal. I wonder if that'll happen in our lifetime. Sometimes I feel like it is, and it's going to. I feel like it's coming sooner than a lot of people realize. I think AI... And with the spinning of the universe and how it's accelerating time, I feel like with the knowledge that we are coming across with quantum mechanics, I think it's just inedible, isn't it? Become an alien species that lives for a very long time. I think it's just a matter of time. I think some of us might have the chance. Cracking qubits and topological tricks. Qubits are also notoriously difficult to control. To explore a new way of lassoing these quantum entities, the researchers assemble a network of qubits into what physicists call a topological phase of matter, a bit like a clump of very small knots. The arrangement allowed the team to play a simple mathematical game without disrupting the quantum computer in the process, a major challenge for its kind of technology. Interesting. In principle, there was nothing too surprising about this experiment. It worked exactly as we thought it would, in theory. But the fact that it did work so well can be seen as a benchmark for this quantum computer. Yeah, which is true. I mean, it seems like we're on the right line. Then we're on the right path. The strange logic of quantum games. Quantum games have been around for a long time and even predated the world's first quantum computer. They are mathematical exercises that allow scientists to explore some of the more out there possibilities of quantum physics, which can also be tested experimentally. Physicist David polarized the idea of quantum games in 1990. In a typical quantum game, 2 or more hypothetical human players receive prompts. They take turns filling out a grid with numbers 0 and 1. The players win in the game if their arrangement of zeros and ones completes a certain mathematical pattern. There's just one problem. The players have to sit there in different rooms, and they aren't telepathic. They can agree on whatever strategy they want to in advance, but they can't communicate during the game. It's relatively straightforward to show that there is no strategy that wins the game with certainty. Quantum entanglement and pseudo-telepathy, right? I think so. Which is where quantum physics come in. Merman proposed that in theory, you could give each player one of the collection of entangled particles. Entangled particles have interacted in such a way that measuring one will affect the outcome of measuring the other. That's true even if the particles are separated, say in the next room or next city over. In a quantum game, players can use these correlations to coordinate these answers. It's a feat so seemingly improbable that scientists nicknamed it the quantum pseudo-telepathy. The practice entangled particles inside a quantum computer isn't so simple. Even the slightest disturbance, such as a minute increase in temperature, can snap the link between two particles. Those sort of errors only stack up the more qubits you add to a quantum computer. Interesting. So the problem is keeping it stable enough. Interesting. The more you get, the harder it's to keep stable. That would make sense. Building quantum knots in real devices. Him and his colleagues wanted to play quantum games in a different way, one that might be easier to win in the real world. To do that, the group turned to Quantum System Model H1. This device runs off of a chip that can fit in the palm of your hand and employs lasers to control a collection of as many as 20 qubits. Wow, that's a lot. In the current study, the researchers sent the computer commands online. They arranged the ytterbium ions into two-dimensional grid so that they generated as unusual quantum structure. Instead of having just 2 or 3 ions that were entangled, the entire collection of ions exhibited an underlying pattern of entanglement, a topological order. It's almost as if the qubits had tied themselves into knots, and those knots aren't easily to unravel. Winning quantum games at scale. We have order that is associated with the global pattern of entanglement across the whole system. If you make a local disturbance, it should mess it up. The researchers took on the role of quantum game players and experimented with the making measurements of various qubits inside the H1. They shown that they were able to achieve quantum pseudo-telepathy and win the game, roughly 95% of the time or more. Wow, that's crazy. The researchers were able to win the game consistently, even when they added outside disturbances and additional hypothetical player measuring additional qubits. Interesting. Noted that of its own, the team game probably won't solve any real-world problems, but it reveals that today's quantum computers may already be able to grow bigger without losing their edge, at least in a few cases. I mean, scalability is everything. This study is proof of principle that there is something that quantum devices can already do that outperforms the best available classical strategy. And in a way that robust is that's robust and scalable. It's true. Huh. Yeah, it's just a matter of scalability, and if you can consistently get it in like a 95% rating and just scaling it upwards. I like this article. This is a good one. Let me know what you all think in the comments. I will talk to you all later. Bye bye. See you later.